This video looks at the sample variance and standard deviation and show how to calculate them from the data. The sample standard deviation is basically a measure of how far the observations are from the mean. The mean here is the average value of the observations. And this sample standard deviation is one of the most commonly used metric to measure the spread of a set of observations. For illustration, let us consider a set of observations which we denote by x1, x2 up to xn. To calculate the sample standard deviation for these observations, we will first calculate the sample variance. And the sample variance is usually calculated through this formula. What we do here is basically to first calculate the sample mean or the average values of the observations, which we denote by x bar. X bar denotes the average value of the observations. And then we sum the square differences and we divide that sum by the sample size minus 1. We would come back later on to the reason as to why we divide by the sample size minus 1. So this is the sample variance. Once we have the sample variance, the sample standard deviation is simply the square root of that sample variance. To be more concrete, let us consider this set of observations. This basically is the weight of 10 babies. So we have 10 numbers here, and these weights are measured in kilograms. What we want to do is to calculate the sample variance and the sample standard deviation for this measurement. The first thing to do, of course, is to calculate the x bar that we have here, the sample mean. And to calculate that, we simply sum all these observations and then we divide by the sample size. We have 10 measurements here, 10 observations. So the sample size is 10, right? And when we do this calculation, we get 3.08, right? This is the sample mean. And the unit of the sample mean, of course, is kilograms because the observations are measured in kilograms. Once we have the sample mean, we move on to calculate the sample variance. These square differences, now that we have the x bar, we now calculate the square differences and we sum them, we add them together, and we divide by n minus 1, the sample size minus 1, which is 9, the sample size is 10. And when we do this division, we get 0.6, right? And the unit of the variance is the square of the unit of the observations. That's why we have kilogram square here. The square comes from the fact that we have squared these differences. With this sample standard variance, we can now derive the sample standard deviation as the square root of the sample variance. So the square root of 0.6 is 0.77, about these numbers. And so the unit here is kilogram. We had the unit of the variance was kilogram square because we have applied the square root. We get this square cancel out. And so the unit of the sample standard deviation is kilogram, the same unit as the unit of the measurement themselves. So this is basically how we calculate the sample standard deviation of a set of measurement. An interesting question that we could look at is, why do we divide by the sample size minus 1 instead of the sample size itself in the sample variance formula, we have this n minus 1. Why do we have n minus 1 instead of n? The answer to this question is that when we divide by n minus 1, we get what is called an unbiased estimator of the population variance. Unbiased here simply means that if we were to go and collect many samples of baby weight, and for each sample we calculate the corresponding sample variance, then on average these sample variances would tend to be close to the true value of the variance of the entire population.